All right, so on number 11, it says, which is true of the data whose distribution is shown right? The distribution is skewed to the right. The mean is probably smaller than the median. We should summarize with mean and standard deviation. Okay, so first of all, is the data skewed to the right? Yeah, it actually is. Is the mean probably smaller than the median? Well, when we have a skewed right data set, that means that the mean has moved to the right of the median. So that means that technically the mean would be larger. So that's not true. On 3, we should summarize with the mean and the standard deviation. Well, the standard deviation is going to be a little wonky since it's skewed to the right. So the only thing that we want to use, or the only correct statement, is going to be that first one. Okay, on number 12, it says the mean number of hours worked for 30 males was 6 and 20 females was 9. Overall mean number of hours worked. Okay, so this is kind of like what we did earlier. You're going to take 30 times 6, and then you're going to do 20 times 9. And you're going to add together those numbers, which is going to give you 50. So you're going to go into your calculator, and you're going to get 180 plus 180 divided by 50. 7.2. That should be B. Okay. George has an average bowling score of 180 and bowls in a league where the average for all bowlers is 150. Standard deviation is 20. Bill has an averaging bowl score of 190 and the bowls in a league where the average is 160 and standard deviation is 15. Who ranks higher in his own league, George or Bill? Okay. So, when you're setting this one up, I would look at, all right, let's go with George and we've got Bill. Okay, so George has an average bowling score of 180. And for all of the bowlers, there's 150, right? And 20 is the standard deviation. So we're going to find the z-score for this mess. Okay, and let's compare them. All right, over here, Bill has 190. And then there's 160 for their average, and then divided by 15. So let's go ahead and do that calculation. We're going to get 30 divided by 20 on the left-hand side. After we subtract, we're going to get 1.5. Over here, we're going to get 190 minus 160, which is going to give us 30. 30 divided by 15 is going to give 2. Okay, so really from that already, that's going to tell me a lot about the z-score. Like this is going to have a higher z-score, but let's go ahead and pull up that table. Z-score table. Okay, this is a negative one. That's positive. .97 versus 0.93. Right? 0.97 versus 0.93. So we know that Bill is going to be larger, right? So is it because his 190 is bigger than 180? Not necessarily, because this is 150 and this is 160. So that's not the case. They don't have the same rank in their league. So Bill must have a higher, his standardized score is higher than George's, which we already see that, right? And that's from calculating that z-score. Okay? If a distribution is skewed to the right with no outliers, okay, which of the following would be true? Okay? Well, if we're skewed to the right, then that means that I've moved my mean to the right of the median, which means that my mean is going to be bigger than my median. So when I skew to the right, my mean goes to the right more. Okay? Let's go ahead. Look at the next one. On 15, it says, suppose that the normal model describes the acidity, pH, of rainwater, and that water tested after last week's storm had a z-score of 1.8. That means that the acidity of that rain okay? And either had a pH of 1.8. Well, that's not what z-score means, right? Z-score is different. It's how it's standardized, right? B, varied with a standard deviation of 1.8. Again, not what that means. Had a pH higher than the average rainfall. Had a pH 1.8 times the average of rainfall. Or had a pH 1.8 standard deviations higher than the average of the rainwater. Okay? So this one, it's going to be E, because when you do the z-score, you're going to use x minus x bar, which is the mean, and then divided by the standard deviation. Okay, if you got 1.8, 1.8 is going to be the standard deviation, which is how high this number is going to be in correspondence to the mean. Okay. All right, so George's score on exam 1 in his statistics class was at the 64th percentile of the scores for all students. Which of the following statements is true? Is George scored a 64 on the exam? No, when we're talking about percentile, we're not talking about what he actually scored. He scored in the 64th percentile. And this is referring to that normal distribution, right? George, or Jorge, yeah, scored better or the same as 64% of the students in the class. Maybe. George got 64 questions correctly. No. George failed the exam. No, because he's higher than that 50%, right? If he's higher than that 50%, then he must have passed. Or none of the above statements are true. So this one should have been he scored better or the same as 64% of the students in the class. And that's actually what percentile is actually going to mean for us. Okay? Which of the following histograms pictured below has the largest standard deviation? Okay, so let's look at this first picture. From the mean, how much does it vary? Well, it's all the same across, so A is not going to work. Okay? For B, it's skewed left. Okay, does it have a really high standard deviation or largest standard deviation? No, not really. Okay. For normal distribution, it doesn't have a large standard deviation because it's normal, right? So it's not really that big. But what about this one? Well, my mean or my median, mean and median are going to be in that middle. So my standard deviation is going to be somewhere chilling out here and here. That's pretty big. So let's look at this next one. Mean, median is going to be in the middle. Standard deviations right here and here. That's a little bit closer than this one. So our final answer is going to be this guy right here. Okay.